Welcome to Advanced Theories channel, where we break down the mysteries of the universe into fascinating stories backed by real science. Today's question is as mind blowing as it gets. Is time travel possible? Not in science fiction, not in movies, but in real physics. Can we really travel through time, forward or even backward? Let's dive deep into Einstein's theories, black holes, wormholes, and quantum mechanics to find out if time travel is just a fantasy or a future reality. What is time? Before we talk about time travel, let's first understand time itself. Time is often described as the fourth dimension, added to the three dimensions of space. Together, they form something called space-time. This idea comes from Albert Einstein's theory of relativity. Imagine the universe as a giant fabric. That fabric is space-time. Objects like planets and stars warp this fabric, and this warping is what we call gravity. But here's the twist. Not only does gravity affect space, it also affects time. Time dilation, the key to forward time travel. Einstein's special theory of relativity tells us something astonishing. The faster you move, the slower time flows for you compared to someone at rest. This is called time dilation. Example: if you travel near the speed of light, say 90% or 99.9% of it, your clock would tick much slower than those on Earth. So technically, you could travel into the future. This is not just theory, it has been proven. Atomic clocks flown in high-speed jets tick slower than those on Earth. Astronauts on the International Space Station age slightly slower than us due to time dilation. So, forward time travel is possible, and it's happening right now, just on a very small scale. Gravity and time, general relativity. Now let's bring in Einstein's general theory of relativity. This theory tells us time runs slower in stronger gravitational fields. This means if you go near a very massive object like a black hole, time would slow down for you. Remember the movie Interstellar? The astronauts land on a planet near a black hole, and 1 hour there equals 7 years on Earth. That concept is based on real physics. So, again, forward time travel is absolutely possible in theory and even in practice, though the technology to do it on large scales is far beyond us for now. Backward time travel, is it possible? Now comes the real challenge. Can we travel back in time? This is where things get weird. Physics allows a few theoretical possibilities, but they are full of paradoxes. Let's explore some of them. Wormholes, cosmic shortcuts. A wormhole is a tunnel like structure connecting two points in space time. It's a solution to Einstein's equations and is also known as an Einstein Rosen bridge. Theoretically, if one end of a wormhole is moved at near light speed and then brought back, it could become time shifted from the other end. That means you could enter the wormhole and come out in the past. Problem: wormholes require something called negative energy or exotic matter to stay open, and we don't even know if such matter can exist in usable amounts. Cosmic strings and rotating universes. There are other exotic ideas like cosmic strings, ultra thin defects in spacetime from the early universe, Gödel's rotating universe, a mathematical model where time loops could theoretically exist, but all these are purely theoretical and highly speculative. Grandfather paradox. Let's say you travel to the past and accidentally prevent your grandfather from meeting your grandmother. If he never meets her, your parent is never born, and neither are you. So, how did you go back in time in the first place? This is the famous grandfather paradox. Backward time travel seems to break causality, one of the most fundamental principles of physics, quantum mechanics, and multiverse theory. But wait, quantum mechanics might offer a solution. According to the many worlds interpretation, every decision or event splits the universe into multiple realities, parallel universes. So if you go back and change something, you don't alter your own past, but instead create a new timeline. This avoids paradoxes but opens a whole new can of worms. Are these universes real? Can we access them? We don't know yet. Closed timelike curves, CTCs. Some solutions to Einstein's equations allow closed timelike curves, path through spacetime that loop back on themselves. These could allow particles or people to travel back in time. Physicist Kip Thorne studied these curves in the context of wormholes, but again, the energy conditions required to make them stable are beyond anything we can achieve. What do physicists think? Some physicists, like Stephen Hawking, believe that nature has a chronology protection mechanism that prevents time travel to the past. Others, like Kip Thorne, have kept the door open if we can find exotic matter and stabilize wormholes, so the debate is ongoing. Conclusion: what we know today. To summarize, time travel to the future is scientifically possible. Through high speeds or strong gravity, time can slow down for you. Time travel to the past is extremely speculative. It's not ruled out completely by physics, but it comes with serious paradoxes and practical limitations. Current technology is nowhere near achieving large scale time travel, but the universe has not said a firm no, so the possibility is still alive. So maybe one day in the distant future, humans will build machines not just to travel through space, but through time itself. If you found this video fascinating, make sure to like this video, comment your thoughts below. Would you travel to the past or the future? Subscribe for more deep physics explorations. Share this with someone who loves science as much as you do. Until next time, keep wondering and keep questioning.